Everyone thinks Europa is Jupiter's most dynamic moon. They're wrong. Europa's icy shell, while fascinating, can't hold a candle to the sheer geological violence constantly reshaping Io. This is a world in perpetual meltdown, a cosmic pressure cooker where volcanoes erupt so frequently and intensely that its entire surface is repaved roughly every million years. Imagine a world where mountains rise and fall, not over eons, but in what, geologically speaking, feels like the blink of an eye, where lava flows hundreds of miles, creating vast, shifting plains, and plumes of sulfurous material shoot hundreds of kilometers into space. We first glimpsed this inferno in 1979, thanks to NASA Voyager 1 spacecraft. Before then, our understanding of Io was limited. Scientists expected an ancient, cratered world, much like our own moon or Mercury. What Voyager sent back was nothing short of revolutionary. Instead of craters, the images revealed a vibrant, colorful surface painted in yellows, reds, and oranges, utterly devoid of impact scars. The only explanation was widespread, active volcanism. The discovery was made by Linda Morabito, a navigation engineer on the Voyager imaging team. While processing images to refine the spacecraft's trajectory, she spotted a massive plume erupting from Io's limb, a volcanic eruption caught in the act. This wasn't just a small vent. It was a gigantic eruption, later named Peel, spewing material over 300 kilometers high. It completely upended planetary science, proving that even small, cold moons far from the sun could be geologically active. So what fuels this incredible activity? The answer lies in Jupiter's immense gravitational pull. Io is locked in a complex orbital dance with Jupiter and its other large moons, Europa and Ganymede. As Io orbits, Jupiter's gravity constantly stretches and squeezes the moon, much like kneading dough. This gravitational tug-of-war generates enormous amounts of internal friction, heating Io's interior to extreme temperatures. Scientists call this tidal heating. It's the most powerful tidal heating mechanism in our solar system, making Io the most volcanically active body we know of. It's an engine of destruction and creation on a scale hard to imagine. The eruptions on Io aren't like Earth's. While we have explosive stratovolcanoes, Ios are often effusive, producing vast, flowing lava lakes and plains. These flows can cover immense areas, sometimes thousands of square kilometers. The lava itself is thought to be silicate-based, similar to terrestrial basalt, but potentially much harder, perhaps reaching temperatures of 1,600 degrees Celsius or more. This allows it to flow incredibly quickly and for vast distances. Beyond the lava, the plumes are striking. They're often rich in sulfur and sulfur dioxide, giving Io its distinctive yellow, orange, and red hues. These materials condense as they fall back to the surface, forming colorful deposits. The sheer volume of material spewed out is staggering. Estimates suggest Io resurfaces itself with about 1 centimeter of new material every year. Over 1 million years, that's 10 kilometers of new rock and ash. This constant repaving means there are virtually no impact craters on Io. Any meteoroid strike is quickly buried or erased by subsequent lava flows and volcanic ashfall. It's a geological clean slate, perpetually renewed. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, provided our most detailed views of Io. It flew past the moon multiple times, capturing high-resolution images and data that revealed astonishing details about its volcanoes. Galileo observed massive lava lakes, some hundreds of kilometers across, with scorching hot surfaces. It even witnessed the birth of new volcanic features and the disappearance of old ones between flybys. One of the most striking features is Loki Patera, a large volcanic depression often seen as a crescent-shaped feature of immense heat. It's thought to be a massive, overturning lava lake, perhaps the largest in the solar system. The plumes themselves are fascinating. They often take on umbrella-like shapes as the material expands and cools in Io's extremely thin atmosphere, which is largely composed of sulfur dioxide from the eruptions. This tenuous atmosphere is constantly being replenished by volcanic outgassing and lost to space. Some of it even gets stripped away by Jupiter's powerful magnetic field, forming a torus of plasma around the gas giant. The extreme radiation environment around Jupiter also plays a role, blasting Io's surface and contributing to its vibrant colors. Io is constantly bombarded, but its volcanism effectively erases these marks. Understanding Io helps us comprehend planetary formation and evolution. It shows us that internal heat, even without a massive planet, can create incredibly dynamic worlds. It's a window into the raw, fundamental forces shaping celestial bodies. Future missions, like NASA Europa Clipper, will focus on Europa, but they'll also pass by Io, potentially offering new glimpses into its fiery heart. The Juno spacecraft, already at Jupiter, has provided some distant views and data on Io's magnetospheric interactions. Io is a testament to the unexpected wonders of our solar system, a world where the very ground beneath your feet is in constant flux, a hellish landscape of unparalleled beauty and scientific intrigue. Discover how another moon, Triton, defies expectations in our next deep dive.